Good morning.
What are you working on this morning?
This is still the review beforehand.
Anything particular on it giving you any trouble?
No, I think just familiarizing kind of which process to use and when.
Yeah, that's pretty normal. Well, while we wait for any others, is there anything you'd like to look at or?
I think the biggest thing is just when using like depreciation, knowing when to do for B1 minus or when it's already in that form kind of.
Hmm.
And I know there were a couple questions where you did need to do
Oh,
1 minus or 1 plus something to get B for
right,
growth or decay ones. But then for other ones, it's like the number was fine without having to do that.
right. So, if I was trying to think of an example, what might I use? Let's use that just because I like problems like that. Let's say you remember we talked about half-life yesterday, right? Half-life of carbon-14. Let's see, we used the 5, 7, 15 yesterday. I think your book likes the 30. That's up to 40, depending on your source. But let's say a sample has lost, let's say, 62% of its carbon. How old is it? So certainly you remember how to do these, right? You first have to find that K.
Right.
So the first thing is just that, top sentence. So we end up with half the amount if we start with a full amount and decay for the 5,730 years. So the natural, I always do H's. I'm doing natural log. The natural log of the 1/2 equals K times 5,730. Chemistry actually starts this way. Chemistry will say, here's the half-life formula. It'll say natural log of 1/2 over T for time. And just, it'll give you this different formula for finding the constant, as if it's a different formula. It's like, no, just solve.
Right.
Anyway, that'll give you our negative 0.0000121. So yes, I happen to remember that I've done half-life problems for so long. So that's our K. Now, the trap here would be, okay, so now we start with our full amount and we decay at our known constant for some amount of time and end up with the 62. But that's not what that says, right?
Right.
The big key is that our tool is about amounts, amount at time t, and amount that we start with. So all of our tools talk about how much we actually have, right? And we don't have 62% of our carbon, right?
Right, because it's lost that much.
We lost 62% of our carbon. How much do we actually have?
So it'd be the 100 minus 62 then, right?
Right. So the 38%. So usually there's a key word there like fell by a certain percentage or lost a certain percentage, something that talks about what the amount of change was as opposed to how much you have. So you use that word appreciation. If it says it depreciates by 62%, that's how much it fell by, not how much you have. Unfortunately, you say depreciated to 62%, and that's back to how much we have.
Yeah, see, and I think that's what was confusing me because it seems so random as far as like when you would do the 1 minus or 100 minus or whatever and not.
Yeah. And it's just those little bits of the language. And the key is always to try to ask yourself, what do I have versus what did I lose? Because often you can't just focus on, well, if I see the word lost or fell or declined, then it's 1 minus. Because all they have to do is change that to, declined to or declined and left you with, and the keywords don't work. We really have to read context. And particularly because when we talk about costs or pricing, we often talk about things like sales, right? Like it's 20% off. Does that mean you pay 20%? Well, no, of course not. But that language we're more used to. But yeah, it's just being really careful with that and stopping and asking yourself, what do I have and what do I usually if you stop and ask yourself that, you're good. It's the I see a number, I see a key phrase, so I'm just going to go this way, where you get in trouble.
Okay, and then the other thing is that when I had originally written down the half-life formula, what I had was A of T equals C, which would be the initial quantity, times 1/2 to the T divided by K. And that was the one that I saw in the book. So it would be like A of T, like A function T, equals C, which would be the initial quantity, times 1/2, and then to like the exponent T divided by K.
Oh, to the V T over K?
Right.
Okay. So this is, say, make that C times 1/2 to the K to the T. That's fine, right?
Yeah.
So that's going to be the same as C times 2 to the negative K to the T, right?
Mm-hmm.
And that's going to be equal to, it's always going to be in here that we're messing with this thing. And that's going to be the same as E to the natural log of 2 to the negative K. Because the E and the natural log would cancel out, right? That's the hard one.
Okay, yeah, I see that though.
So C times E to the negative K natural log of 2T. Or instead of calling it C, call it A naught. E to the, instead of calling this your constant, change that label to, well, I don't want to use a K again, but let's say W times T. They're just different labels of the same model, essentially.
Okay, so that still is a valid way to write it out and solve it then.
Absolutely. And that's one of the things that you'll see. You'll see also Newton's law of cooling. They've got the temperature at the beginning and the all the P minus T naught either. It's all the same formula. It all breaks down to this if you want it to. Fair.
Gotcha.
And this book's not too bad with saying here's a different formula for every scenario. But we had a couple books a while ago that were, or a couple of editions of a book like 5 or 6 years ago, where every different problem, it basically built this new formula. And it drove me nuts. I was like, don't just use this for everything. And you have one tool and it always works. And I actually had a person go through and change every problem into using this tool for it. And he came back and he went, it really worked for everything. It's like, I know. Why would I tell you that? You know, but I went and I checked. It really did work for all of them. So there are other ways to do, like if you do regression in your calculator, one of the reasons I don't like playing with regression too much in here is it's a b to the x, but that b is just the e to the natural log of b times x. So you can turn anything into a base e if you want to, and then everything's in natural log, everything agrees with everything else, and it's just, life is better in my opinion. That makes sense?
Yeah.
I struggle with that too, because like you'll go through a problem and you'll have an exponential equation with e, and then you'll go through on the my open math and it'll be like use exponent regression, and the equation's way different than what we're used to seeing.
It's equivalent to what you're used to seeing.
It's equivalent, but it's not. It just throws you off because you're
Yeah.
not. You're used to the way that you've been teaching us, and then my open math's like do it this way, and it's different.
And actually, if you use regression in Excel or a couple other pieces of software, you can actually do it with E instead of AB, and it's nicer. But again, that nice thing, if you've got, say, 5 times 1 plus or 1.4 to the x, and that's your model, but you don't want that model. You want the a e to the kt model. Well, that's a times e to the k to the t. So that 1.4 is what your e to the k is equal to. Well, how do we put it in e to the k? The same way I did in that one I erased. That's 5 times e to the natural log of 1.4 to the x. So that b there becomes a natural log up in there, and you've got ex times the natural log of 1.4, and that becomes your k, is the natural log of whatever the old base was. So once you get used to doing that, you can go back and forth between those models all you want. It just takes, doing that a fair amount. If that's helpful. And for those of you guys going into calculus, that's actually one of the things that we do fairly often. You'll end up with a statement like, oh, your book likes these, x to the 5th, y to the 4th over the cube root of z. And you'll be thinking about, okay, I need to use my calculus tools on something with this structure, and oh, it's just going to be a pain. You got a product, you got all the powers, you got the division and the radical. It's just irritating to work with. So what we end up doing is we say, okay, I don't want to work with that. I want to use a logarithm. I want to put in the natural log of that, because we know that the natural log, or any logarithm, we tend to use natural log, gives us extra manipulating power. Well, how do we put that natural log in there? Well, we just put e to the natural log of that power, because those things are equal. The e and the natural log would cancel each other out. Why do we do that? Because it gives us this natural log in there that we can then manipulate. Now, for your guys' homework and your guys' practice, all you've been doing is looking at, hey, how can we manipulate this? Where's that going to come up later, though? It's going to come up in what we call logarithmic differentiation. And you guys have done those, right? Where you separate that into that minus that one, right? I'm not making stuff up here, am I? If so, I'm glad, because it is one of those things you want to make sure you can do. And the 5 comes down, plus 4 natural log of y, minus 1/3 natural log of z. And yeah, technically, to put that natural log in there, we'd have e to that power. But it might seem surprising, but using your calculus tools on this is super easy in comparison to using it on that. It's just the fact that it's an exponential doesn't really cause any trouble. Addition and subtraction is so much nicer. Multiplying by constants are nicer. Taking the derivative of logarithms is really easy. Where here, having this product rule and quotient rule and 3 chain rules, it's a pain in the butt. But mostly I mentioned that just to emphasize this tool of, I want a logarithm or I want an exponential. So just, you could take anything, take the 5. Well, that's e to the natural log of 5. If I want an e or want a natural log, now we have them. So what else you guys playing with? Aaron, you were mostly asking about the subtracting. Did that help with that a while ago?
Yeah, definitely.
Okay. Justin or Andrew, you guys fighting with anything in particular?
I had a problem yesterday. I gotta find it real quick.
Okay. Justin, what about you?
I mean, nothing in particular besides my own motivation and my boss at work last night. But, you know, that's a different matter.
That is. Let's see. So it's been a while since you guys did 5.1 and 5.2. One of the things that sometimes happens in chapter 5 is, you know, you do 5.1, 5.2 to get ready to do the inverses in composition. And then we spend a bunch of time talking about logarithms and exponents. Do make sure you go back and look at that 5.1, 5.2 stuff, just to make sure it's also fresh, if that makes sense. What else would I want?
Yeah, I had a question from the review, but I can't figure. I forget which one it is, so I'm kind of clicking through right now to remember which one it was.
That is a long review, isn't it?
Yeah, 39 questions. Oh, here it is. It's number 3 on the review. Can't remember if it was 3 or 13. I knew it was one of those. I knew it had a 3 in it. Number 3, and then the other one was number 5 or number 4. I had a hard time with both of those. We were learning them, and now I'm a little rusty on them as well.
Totally reasonable. So number 3 is probably mostly in the manipulation. Number 3, we're trying to find both of those compositions. So the f of g, we're going to be putting that function g into f, right?
Yeah.
So f composed with g of x means we're going to take f and put in the 4 over x plus 3. So f says whatever its argument is goes in for that x. So 1 over the 4 over x plus 3 minus 3. Fair? That's a start.
Yeah, and then we can just drop those parentheses, correct?
Yep, the parentheses aren't doing anything, so when they drop away, those 3's are going to undo each other nicely. So we'll have 1 over 4x. Sorry, 1 over 4 over x. So that's 1 times x over 4. So it's just x over 4.
Gotcha. See, I couldn't remember if we were allowed to drop those parentheses or not.
Yep.
That's what was
If
messing me up.
Sometimes it helps. It may or may not. But sometimes if people are like, okay, I'm worried about those parentheses, put a 1 in front.
Oh, then multiply across.
Yeah, and then kind of go, okay, what would I do with that 1 in front? Well, I'd multiply them and it wouldn't do anything. Okay, so those parentheses are safe.
Okay.
As opposed to if you had, say that, and went, okay, if I put a 1 there and I distribute, I got to distribute that negative with it, right?
Yeah.
So sometimes like, okay, make there be a distribution there so you have something you have to do so you can think through what happens. That can sometimes be helpful.
And the other one was number 4.
And of course we have to do that one too, but let's just do that one real quick, just for the fun of it. So that would be 4 over the 1 over x minus 3 plus 3. And that's, let me be careful about how I wrote that. Oh no, I wrote that. Fine, the minus 3 is down there. But again, you got a fraction in your fraction. So you could either multiply by the reciprocal or think of it as multiplying top and bottom by x minus 3. Either way. So 4 times x minus 3 plus 3. Can we cancel those 3's?
No, because you have to show you the 4 first.
You wouldn't cancel the 3's.
The 4 right out front.
Not with the 4 out front. So what, minus 9?
Yeah.
So yeah, those were mostly just, being careful about those operations. Oh, and 4 is similar.
Square roots just mess me up every time. I don't know why.
Yeah. Well, and particularly it's asking you domains as opposed to asking you to find them. So that's adding a wrinkle into that question.
I think that's what is the hardest part for me. Is the domain.
So let's talk about domain for a second. If we go off and just look at f of x is x plus 9. What is the domain of that function f?
X can't equal -9
Why not?
because it would be 0.
What's wrong with the 0?
Oh, I guess there's nothing wrong with the 0. Never mind.
If it was in a denominator,
Yeah,
absolutely. But
that's not.
not in a denominator.
It's going to be all real.
So all reals. So, or the interval from negative infinity to positive infinity. When we look at g, it's square root of x plus 10. What's the domain just all by itself for g?
Can you take the square root of 0?
What's the square root of 0?
Like 0, isn't it?
Then you just did.
That's the thought that comes to mind.
Yeah.
So then it'd be all real as well, right?
Well, we can't take the square root of a negative, right?
Oh, that's true. So it can't be
So
what,
x plus
like
10's got to be greater than or equal to 0.
yeah.
So x has to be greater than or equal to negative 10. So from negative 10 to infinity.
Yeah.
Fair?
Okay, that's right.
So for f of g of x, if we want to track our domain, so our domain is the x values that we can use, essentially. So those x's first have to be able to go in onto G, right?
Yeah.
To be able to go into G, you've got to be negative 10 or above, right? Automatically from G, it's got to be negative 10 to infinity. And then once you've gone into G, G's outputs have to be able to go into F, but anything can go into F. So the fact that it's being composed with F doesn't change anything.
Okay, so basically for that one, you don't even have to write it out because you know that F is all real.
Frankly, we should never have to write it out. But often it's nice. But yeah, particularly when one of them's all unreals. So
Probably write about it every time to help me think.
which it's a good habit. I just kind of wanted to talk through the logic, but you're right.
That's fine.
Writing it out is a very good habit. Now, when we do the G composed with f of x, for x to be able to go into f, all reals, right?
Yeah.
So that's no problem. For that f's output to be able to go into G, f's output has to be bigger than negative 10.
Right.
So f of x has to be greater than or equal to negative 10.
Correct.
Okay, well, what's f of x? It's x plus 9. So x plus 9's got to be greater than or equal to negative 10. Subtract the 9, subtract the 9. X has to be greater than or equal to negative 19. Fair?
Fair. That makes sense.
Cool.
Okay, I get it. See, I always write them out, and then I like, how do I figure it out from here? But looking at it that way makes a lot more sense.
Good. I was hoping it
Me
would.
at least.
Like you look at it like one way for a while, it's kind of like, but it's nice. But, still you take the x plus 9, put it in there for the x, and you'd get the square root of x plus 9 plus 10. And, we'd probably start like that, but the parentheses, again, aren't doing anything.
Yeah.
So we'd have the x plus 19, and that x plus 19 has to be greater than or equal to 0. So you end up with the same thing.
Yeah. Makes sense.
Particularly when one of them has restrictions and the other one doesn't, it can be nice to just track your inputs, because that's really what's happening there.
Okay. That's about all of my questions.
Cool.
I don't know if anybody else has some.
Justin has questions about motivation and standing up to bosses.
I have motivation questions, but it has nothing to do with work.
Oh, and I am the last person to help answer motivation questions. I got
Just
nothing.
like the whole online thing is like sapped my will to do schoolwork. Like I'm so tired of sitting in front of my computer for hours on hours trying to get stuff done.
I think I sat down. It was one day last week. I had a department meeting after my classes, and then a curriculum meeting, I didn't get out of my chair for almost 10 hours.
I've had several, at least, I would say 9 or 10, 8 to 10 hour days in front of my computer.
Now, of course, what I did afterward was I, got up, got some food, came back and played video games on my computer. So
That's different. It's
it is
different.
totally
entirely.
different. And no one can tell us otherwise.
It's an entirely different beast.
Yes. That's why I spent money on the comfortable chair.
So,
Anything I can do for you guys today?
no, I think I'm good.
Go take a test. Whenever you want.
But yeah.
If those links cause any problem, let me know. I did check them this morning. Somebody went and tried to go take it yesterday, and I got a nice little message that was like, "It's all filled with trig." It's because that wasn't your real test. It was just a placeholder, and they panicked. It was fun. The real one comes up now. And I don't think there's anything on this that's going to give you guys too much trouble. But we'll see. That's the point, right? Particularly if you've done all the homework, right, Justin? That's why I would randomly pick on Justin.
So you're calling me out today. I'm almost there.
Yeah. I know you picked that up a lot.
Oh, hey, Matt, I was wondering if I could get a couple more late passes because I might need them at some point during this term.
There's only like a week and a half left.
Yeah, and I still might need them. Trust me. I've been trying to space out the ones I had, and there's a couple times where I stayed up really late because I didn't realize I had one due that night. And I was like, oh, God. Just float me a couple more. That'd be fantastic.
All right.
I have an extremely dense workload for the last week and a half.
That's reasonable.
It's a struggle.
Anybody else
right now.
want one?
I mean, I wouldn't complain about it.
As opposed to Aaron, who'd be like, no. I don't know why you got that voice all of a sudden. All right.
All right. Thanks, Matt. Appreciate it.
Anything else I can do for you guys?
No, that's it. I'm going to go study some. I'm going to take
Okay.
the test.
And I'll be around here, so send me messages if anything weird comes up.
Ready? I will.
Okay.
Oh, I got to send you an email still. I found 5 and 6.
I haven't
found
looked at that
7.
email yet, but I saw it popped up, so I'll check that out.
Okay. I guess. I don't think I have. Oh, that might not be me. I haven't sent you one yet. I was going to today, this morning.
Oh, that wasn't you. That was just somebody else's hand in.
Nope. I'm looking for one more of them
Okay.
to see if I have it before I send an email. If not, I'll just send an email and tell you I can't find it because I can't find it.
Which is fine.
I know I did them, but they're somewhere in this mess.
Give you
So.
some motivation to clean.
Well,
Will make the
most of
boss
it's-
happy.
Yeah, probably.
Yeah, that was another thing that distracted me was we had an inspection that I had to do, but it was like over the phone for the rental people.
Yeah.
So this weekend we had to like clean the house for that. And I was moving a chair and I broke a window.
Oh, jeez.
Like, oh my God. Right before I had to take these pictures, so I got to tell them, hey, yeah, I broke this window, but I'll pay for it. Like,
Love the fact that I own my house. If I break shit, I just have to fix it. And if it's not that bad if broken, I can live with it.
Yeah.
The sink in my master bathroom was broke for like 3 months. I was like, fuck it. I own it.
I got a lock on one of my doors. It's been broken for 4 years. I keep looking at it going like, I could fix that in like an hour. It's just,
Well, so here's the thing, right? Is like, I was doing okay financially when the stimulus check hit.
Mhm.
So I was like, what do I need to fix in the house? I was like, well, I need a new sink in the master bathroom. And I have background in plumbing. I have too many trades, first of all, like carpenter, plumber, floor installer, construction, framing, all this other job. I've done so many jobs.
Not a
So
bad thing.
my wife's like, well, I want this really, really nice sink and faucet from Lowe's. It's like $500 in sink and faucet later. She has this big, beautiful square sink and this huge curving faucet that you can turn and does all pretty and stuff. So
Nice.
So I was like, yeah, I just cut out the counter
Sink
and
does
put
your
a big
taxes.
sink in. Yeah, right. Pretty much. Like this is a bathroom sink that you can actually turn like a kitchen sink. I'm like, what? Why? What is the purpose of this? She's like, I like it. And I was like, okay,
That's enough.
yep, I'll do it.
Okay, you guys go take a test. Let me know if anything happens.
Well, wow.
Okay.
Sounds good. Thanks.